In many tech companies, including some places I've worked, having a bug or an issue in the code that's seen by the general public can be a massive problem. At large companies like Google or Facebook, for instance, having users experience no service or even small bugs for just seconds or minutes could result in literally millions of dollars in lost revenue. Even if you work with the best developers in the world who never make mistakes in the code they write, with larger companies, there's potentially upwards of 10 to 50 developers working on the same areas in the code at the exact same time, which can make it almost impossible to judge whether something is bug-free. Using a version control technology like Git, developers download and then make changes to the most current version of a code base. Then they upload their changes to be compared with the changes that others have made in the same time span and resolve any conflicts in the code that come up. Sometimes, things look fine at first glance of the combined code. Yet problems are discovered when all of that code is compiled and tested hands-on as the end product, like a functioning website or a mobile app. So it should come as no surprise that in modern programming for web and mobile applications, no matter the size of the team, there's several safeguards to ensure the final product visible to the end users is as bug-free as possible. The first safeguard is version control, ensuring the code changes made by everyone appear not to interfere with each other. Typically, the place the engineers put their code after changing it to check for conflicts is something called a staging branch or integration branch. Then, the next test of the code is to see if it would actually run together in a real-world scenario. So it's run as a whole program in what's usually called a staging environment, which has all of that staging branch code run together into an actual usable form, whether that's a testable website or version of the mobile app. In the staging environment, people like product managers, engineers, designers, and QA engineers can do various quality assurance tests on the compiled code in special, internal, non-public environments to make sure everything works like it should. We click buttons, we try new features, enter data, and generally mess around, make sure everything looks really solid. Once something has passed the rigorous testing, it's then put into the next tier, the master branch. The master branch, or server, is exactly what it sounds like, the most complete and demonstrably working copy of the code base. Once there in the master branch, the code sits and waits to be moved, or deployed in engineer lingo, to the most important server of all, the production server. The production server holds the code base and all compiled experience available to the end users. If you're using any application or website on any given day, you're using the production code on the production server. Having the master branch before the production branch is useful because sometimes things will pop up unexpectedly even after rigorous testing in the other stages. That way, changes can still be made before the next version of the app is sent to the end users via the production branch. It's important to know that not all companies or engineers use these exact same names and flows to eventually get their code to production. Sometimes the testing is done primarily in the master branch, and sometimes the flows will differ entirely. But let's recap the most important point here. There's usually several servers or branches that engineers use to check and test code to make sure everything is fine. One safe bet you can make, though, is that production code is always the live version, and master is always the step right before that's used for final checks.